Hi, this is Huilong Wang, and I'm going to present a report of my licensing challenge via Weka. And first of all, I want to present my dataset from website. Um, it's a dataset about red wine quality, and it has 11 attributes of red wines like fixed acidity or volatile acidity and citric acid, something like also about pH and density and alcohol. And the last column is quality. Since the column quality is all by number score between 0 and 10, so I wrote some Python script to identify them, classify them as good and bad and normal. Then let's take a look at our data set, what our data set looks like after data processing. And open here, because it's a CSV file, you have to, here it is. You can see it still has 11 attributes, and the last column of quality has been changed into normal, good, and bad as well. But the bad is really it's not too much since it only has 10 examples of them. We can find it in the data visualization part. And here is what it looks like in pre-process part. Then click the quality, and as you can find that the normal, the red wines which are labeled with normal has 1,372, and the red wine labeled with good has 217, and the bad only 10. So, and also we can do some visualization about the correlation between the quality and the pH and the density. And let's see, also the sulfur dioxide, and it's obviously that the less sulfur dioxide being less, the wine with labeled like good is more. And let's go into the next part of classify. And I chose to use the tree.j48 as the first test, and with here with 10-fold cross validation. Here is how it's been classified, and we can find that the labeled correctly classified has 87%. Then we can visualize the tree of it, but because it has 11 attributes, so the tree looks like really complicated. Then what I want to do is narrow down the trees. So what I'm going to do is choose J48 and choose set a limited of the minimum number of objectives, which will make the leaves of the number of the leaves being less. Then let's just try it with 5. And okay, see. Yeah, you can find the leaves got not too much like before. right? But however, it makes sacrifice to the correction of classified, because if when we have a larger number of leaves and larger size of the tree, the correction of classified instance being more than the one with less leaves and less size of the tree. Also, since the dataset has not too much red lines with labeled bad, the cross-validation is more suited than percentage split, because each fold can be assigned some red lines labeled with bad. But if we use percentage split, the red lines with labeled with bad could be assigned into both. All of them could be assigned into the train set, or all of them could be assigned into the test set, which will lead the classified process cannot classify the bad red lines. And what's more, I also try to increase the folds of the cross-validation. Let's see, here is the trees.j48, also the same one. And I try to, I give it 18-fold validation, cross-validation, and it leads to higher correction as 88%. Here is with 22. Since the fold, since I assigned too much fold, so it leads also another decrease in correction of the classified instance. And I tried too much times. And then I also tried to use random forest to compare with the J48 tree. As you can find that the correction of the classified of it is being higher 2% than the J48. Yeah, the highest one, J48%. And as for this random forest, I use 10-fold cross-validation. And also I try to increase the fold in using random forest. It seems it doesn't impact the correction or classify too much. So you can find it only decreased in percent of 0.06. Yeah. So that's it. Thank you.